Before we get started, I want to make sure the people who put so much of their personal time into hosting amazing community events like this get their recognition and appreciation. So please, let's put a huge round of applause for all the organizers of Star Trek. This is my second time here. I'm very happy to be here. This interaction that we just had was a synchronous interaction. I said something, you heard it, you immediately reacted. Throughout the talk, you could raise your hand and ask questions in the between. And we would celebrate the simplicity of synchronous execution there as well. But since most people are watching me on a screen right now, you would probably take the more asynchronous route by trying to remember all your questions until the end. At which point, you might need to bring back some of the relevant context before you could present that question. Or maybe something else came up in the meantime, and your question changed, or you don't need to ask that question anymore. There's a lot of uncertainty with async things. You could also potentially track me down on social media, where you could ask me those questions. Speaking of, hi, I am Dev, and I'm a dev. I have been building full-stack JavaScript applications for about 8 years now. Currently, I work as a developer at Zolvio. It's a little, I've been told that that name is a little hard to say, but it's an agency that's heavily into GraphQL, event sourcing, and AI. So if any of those things sound familiar to you, please hit me up after this as well. I sometimes contribute to open source. SolidJS is a front-end framework, kind of like React, but much better. And TanStack Start is a full-stack framework for React and Solid and maybe other frameworks soon as well. If you do anything in React, you've probably used one of the libraries in the TanStack ecosystem, primarily TanStack Query. I also make content on YouTube about full-stack development and software architecture. So if you like my talk today, make sure you also check out some of my content. And I am terminally online on X, so you can always hit me up there and ask me any questions. I love chatting about software dev. All right, so this talk is about building asynchronous UIs without a hassle. I'm going to try to convince you of 3 things. Synchronous state is simple. Asynchronous state is complex, relatively. And we, as in the front-end ecosystem, has finally found some ways to make async relatively simple. Let's go through what that is. Oh, I missed one. Synchronous state has been simple or easy ever since frameworks like React, Vue, and Angular made it easy pretty much. Because they allow us to model our applications as some synchronous state or some state, and UI as a synchronous derivation of that state. Sure, there's still asynchronous things going on in our apps, like event handlers. They are asynchronous. But as long as any asynchronous event can be represented as a new state in our application, we can handle it. So we define all the different states that our application can be in. We define how each state is reflected in the UI. And we simply move between these states as asynchronous events happen. This is a fantastic programming model to build dynamic and responsive applications in. That said, it hasn't been all easy. Having to represent every state of our application can be a bit tedious and complicated. So we had to come up with more patterns to help us better manage that complexity. This gave rise to state management solutions like Redux, with its reducer pattern, where you define how that state can be mutated right along with the definition. Or MobX that adds a layer of derived values and fine-grained reactivity on top of it. Or XState that introduces finite state machines as a way to model our states, along with the transitions between those states. Now, initially, we use these frameworks to build little embedded widgets or islands of interactivity within our websites. So we would render the entire HTML page on the server using all the data that we needed, and then we use these frameworks to add synchronous interactive bits on the client side. But at some point, we started to build complete applications with these frameworks, especially with the advent of client-side routing. And one of the biggest challenges while building full applications with this was doing asynchronous things like fetching some data or fetching some code or triggering actions like post and delete requests. This might hint at why that's the case. The code here is the simplest way to fetch some data from an asynchronous source like a server. And that also covers intermediate states and race conditions. It doesn't even have any fancy features like refetching or caching. This is the minimal amount of mental overhead that needs to happen when you deal with asynchronous state in a synchronous system like React. Again, this example is in React, but it would look very similar regardless of what framework you're using. Let me dig more into why this is the case. Here we have 3 states that our app can be in, A, B, and C. It's pretty straightforward. We can go from A to B, B to C. Let's say the 4th state, D here, is an asynchronous. It means we cannot exactly just switch from C to D. There's an async operation here, maybe a call to the server. It has to complete before the state D is available. Some time has to pass between C and D, and we don't exactly know how long. We have to assume that the user is going to notice it. Not just that, we have to assume that this async operation might fail. It could be for many reasons. So we inevitably have to create 2 additional states, as well as a branch. For every state that requires an async operation, we need at least 2 additional states, synchronous states, to represent the state where it's not really yet resolved or the state where it errors. And this complexity just keeps adding on to itself. Imagine once we reach D, we now also need to go to E, another async state. So we have another one of these forks. This could either be another screen of the app that needs data from the server, or this could be a post request that we have to go to the server for. Or maybe we have D and D as separate operations, but combined onto the same state, as you see in the 3rd example. Which means now we have something like that. I'm pretty sure you have experienced these sort of cases, either in apps that you use quite frequently, or maybe even apps that you have built yourself. This is not just a complexity problem for the developer. This is a user experience concern as well. If you have a page with 5 different async operations that all need to settle before you can see the page, your user might experience 5 different loading states. That's not great. And if you go to x.com, you're going to see that exact same thing. That's not where the problems with async even end, because of something called race conditions. It's where you have multiple async operations happening at the same time. And if they resolve in the wrong order, the application might enter into unexpected states. This here is a non-race example where we first enter D, it resolves, and then we go to E, and we wait for E to resolve. Everything is fine for now. The problems start coming up when we switch to E while in the middle of the D operation. It hasn't resolved yet. Now, there's 2 possibilities. The first is that D gets resolved before E, in which case we might show D for a little bit, and then we switch to E. The other possibility is D resolves after E, which is much worse, because now we show E for a little bit, and then we switch to D and get stuck there. So the 2 options are the wrong state flickers in before the correct state, or the correct state flickers in, and then you get stuck on the wrong state. Neither of them are really good. What we actually want to do here is somehow ignore or discard the result of D as soon as we have switched to E. This way, we'll make sure that we never flicker in the correct state, or worse, get stuck in the wrong state after flickering in the correct one. Let's see what some of this looks like. I'm going to try to, let's see, mirror. All right, so I have a demo here. This is a very simple conference app with a lot of dummy data here. So I'm on the wrong branch. Let's make sure main branch. OK, let's refresh. So this is, we see a loading schedule page, loading schedule data, speaker data, and then we see our schedule here. We can navigate to a different page. We'll see a loading state again. Same thing here. And you can also click on one of these, go to the session page, and see the session details here. So loading speaker details, and then now we'll see the speaker here. We also have a little bookmark button here. This doesn't actually go to a server. It's all like local async operations just to emulate asynchrony. But in the real world, this would be talking to a server. So I click this. It goes, disabled for a while. And then once it's done, we see loading bookmark status again. So pretty straightforward. Let's see what the code for an app like this looks like. Let's hop into our app.tsx here. This is using React. But again, if you've used any front-end framework, this should be relatively familiar. OK, so we have a mini router here. So we can be on the session page, or the home page, or the login page. And we have a piece of state that represents this. Please don't do this in real apps. Use a real router. But this is just for demo purposes. And again, here we go over all the different branches. If it's the home page, we show the schedule. If we are on the session route, we see the session details page. Let's see what this schedule component looks like. Here we have the active tab. So are you looking at day 1, day 2, or day 3? Star Trek is single day, so it makes it pretty easy. But here we have, let's say, 3 days. Then we have a hand-rolled hook here called use async data. You might have something like this, either hand-rolled, or you might be using React Query. Please use React Query again. It has everything that you need. But let's say we pass it in a function that's going to go to the server and get back the schedule for a single day. So you can see that it returns a promise of an array of sessions. We get back a status here, so pending success error, the 3 different states that I talked about. And we get our data, which is an array of sessions, or null, if it hasn't yet resolved. Same thing here. We also want to fetch the speaker details. And once again, we have 3 different states, pending success error. And we have our data. Coming down here, we have our tabs. And here now we have to check if both of the statuses are successful. We are going to show our data. If not, we have to handle a bunch of different pending and error states. So you can see that every single operation adds a bunch of overhead when we are trying to build our UIs. Now, these are very, very simple. But for building actually good user experiences, these are going to have to be a lot more detailed. And when you're handling errors, you're going to have to provide some way to either navigate to a different page or retry automatically or something like that. Let's also see what the session details page looks like. Once again, we have our use async data, which we use to get the data for a single session, the session that you're on. Then we have another one where we get the speaker. So we're going to check if the session exists and then fetch that speaker. If not, we're just going to return null. So once again, you're going to see the status, the data here that could be session or null, and the speaker that could be speaker or null. Again, very familiar with all these patterns. We also have an action hook here. So we can execute an action to toggle the bookmark on a session. And again, we have a status that tells us like what is the state of this action. Are we executing it right now? Did it error? Or is it done already? Then again, we have to check. And we are not even handling every status here. We're only handling session status. We are not even handling speaker. So again, if pending an error, show this UI. If not, come down here. If bookmark status is pending, show this. If not, show the button. Yeah, same thing here. So this is what the average developer experience for building asynchronous UIs look like. Now, we have gotten incredibly familiar with all of this over the last decade or so. So it's become kind of second nature for us to just automatically handle them. But this is still overhead. We can also quickly see what these hooks look like. I'm sure many of you have written a version of this at some point. We have our status as a state. We have our value and error. And then obviously, every time you execute, every time you want to fetch some data, we're going to set all of these states. We are going to call our async function and then set the value and status. Or if it's an error, we set the error and the status. OK, nothing too fancy here. Let's move on. OK, stop mirroring. All right. So now there's actually another problem, which you might have noticed or you might have noticed in your apps, which is how inefficient sometimes this can seem to be. There's some cascading client-server waterfalls going on here, which is where the client makes multiple requests to the server in a series, like in their first example. Looks like the images are not loading, have not loaded fully, so some of them might be a little blurry here. But yeah, I have a whole separate talk on this specific problem that I presented here last year. The TLDR of that talk is that there's a tug of war between hoisting our data requirements up, so pulling them outside of your UI components and putting them into a separate system like a router for efficiency, versus co-locating them in your UI components where it's actually used for better maintainability and composability of those components. What's that talk from last year for a deeper dive into this? And the reason why this is a separate talk is because the solutions, the technologies and approaches that are required to solve this problem are different from the ones that I'm talking about today. And they are kind of like different problems. OK, let's see how we can fix the things that I talked about today. How many of you know what delimited continuations are? OK, basically no one. How many of you are familiar with try-catch and async await or generators in JavaScript? Everyone. OK, good news. You're all familiar with delimited continuations. Let's quickly compare how we did asynchronous stuff before we got async await, when we had promises. We had this data structure that represented an asynchronous value that hasn't yet resolved. And for every promise, we defined a success and an error callback. Now, there were we could chain them together, so we only needed to handle like error at the end. But async await really simplified this by giving us imperative access to the resolved value by putting the await next to it. It also made error handling, like in a sense, optional, because it hooked into the existing try-catch system. Try-catch gives us a way to model just the happy path for as long as we want to, and allows us to arbitrarily choose at what point we want to handle the error in the system. And we do that by simply wrapping an expression with this try helper. Now, I don't like everything about try-catch. And sometimes I prefer the errors as values approach, where the function that could cause an error just returns it. But it's very hard to deny that the try-catch approach is very simple and intuitive. And it's why most languages try to stick to it. So what would that look like if we did this in a declarative model like React? We could eliminate the need to handle all these intermediate states, the resolved and the error states. And instead, we could have a model where async state can simply be seen as another synchronous state, like async await. We are not forced to handle the loading and error case, and we don't even need to handle the state where the value is undefined. OK, pretty bold claims. Once again, let's see what that looks like. All right, I'm going to switch to our suspense branch. Once again, we go into our app. And the app is pretty similar. We still have our router. We are still going over all the different the routes that we have and rendering the correct component. Ignore the commented out code. I'll get to it in a second. Let's look at the schedule page again. Once again, I'll explain these in a bit. But we have our active tab, day 1, day 2, day 3. We have our tabs component. And we have this day schedule component, which if we come down to, this is where we fetch our data and we render our UI. So you can see here, we are still using that hook. That hook has changed implementations though. But if we call getSchedule, which returns a promise of a session array, the value here is a session array. It's not session array or undefined or null. It's just the data that we have fetched. And we don't need to handle any statuses here. We don't have those intermediate states. All we have to do is to come down here and map over our sessions. We don't even need to add something like this here, because we know that this value cannot be undefined. We are treating it as another synchronous state that our app can be in. Same thing here, speaker array, and this returns an array of speakers. And what you might notice is the things that we are not doing. Again, we are not handling the pending status or the error status for every operation that we have in this component. Let's go to our session details page. Same thing here. We use the session ID to get the session, which just returns the session data, which means we can now go in our speakers, and we don't even need to handle the case where the speaker is undefined, and then we just return null. We just say get speaker with the speaker ID, and we get back a speaker. And nothing else needs to be added here to handle those two intermediate states. OK, but how does that work exactly? How does that look like? Let's refresh here. We're seeing a blank page, and then we see the entire page here. We don't see any intermediate states because we didn't define any intermediate states, and we don't need to. If I switch to day 2, I'm going to click, and it switches. Click, and it switches. So when we transition to a new state that requires some async data, we just wait for it. We wait for everything to resolve, the entire next UI to be rendered, and then we switch to it. Let's click on one of these. I clicked. We're waiting. We're waiting for the next page to render, and we see the entire next page. We don't see a bunch of different intermediate states in here. This model guarantees that we are always going to see consistent UI in terms of like asynchronous consistency. And we are not going to see UI that tears or something that shows an older value and a newer value at the same time. Same thing here. If I click on this, it goes to this. It does go to this pending state because this is an action that the user is doing. But then we see the entire new UI here. OK, this is good in terms of not having intermediate states. But we had those states for a reason, because now the user experience sucks. If I click go back, the app seems frozen. It seems stuck because there's no insight to the user on what's happening. So this default experience is good, but it's not great. So, but again, remember the point of try catch. It's not to stop you from handling errors. It's to let you opt in where you want to handle errors instead. So let's hop back into our code right here. Go back to our app and bring back the suspense fallback here. So we can take any part of our UI. In this case, we're taking this entire main, all the UI in here, which is basically our entire app. And we're wrapping it with this suspense component and providing it this fallback. What does this do? I'm going to rearrange this. OK. So if I refresh, now I see this loading here. This is the fallback of the suspense component. Every time I click something, every time there's something asynchronous happening inside suspense, it's going to trigger to fallback. It's going to make sure that some UI is being shown while something asynchronous is happening under it. It doesn't care what asynchronous is happening. It just cares that something is not ready, which means we need to show our fallback. I click here, and again, we go the suspense fallback, and then we see the page. What's nice about this is that we can nest them like that. So I'm going to wrap the session details page with its own suspense. So now if the session details page has something asynchronous going on, it's not going to trigger the top level suspense. It's going to trigger this one, which is where we see loading session details very specifically. Let's save it. Now we see loading session details. The homepage schedule page still shows the global one. Let's fix that. Let's go into our schedule component. And we have the day schedule, which fetches our data using use async data. So I'm going to comment it out, and I'm going to bring this back, where we say the same thing, but we now wrap it with its own suspense that says loading schedule. Let's save and go back. Look at that. Now the entire thing doesn't go back to fallback. We still see the tabs here, so we can switch between them. And we can see the schedule has its own fallback. OK. But what happens if something goes wrong? So I'm going to go to our get schedule. And I have a little bit of code here that throws an error half of the time. All right, let's go back here. Oh, error loading schedule. Why does that happen? It's because we also wrapped our day schedule with an error boundary. So now, this fetch here might fail. But we don't care about that in this component. Here, all we care about is how we are going to render this data, how we are going to show it on the screen. This error boundary, again, similar to suspense, makes sure that if anything inside it fails, we're going to switch to this fallback. Let's go up here and refresh. Error. I should probably remove the ... OK. If I go to a different page, looks like it's failing too much. I need to make this, let's say, 0.8. Refresh. OK, we see the schedule. We go up here. We see it again. And now we see error. And it kind of gets stuck there. But the point is that we have something above that decides what to show if anything errors. And we can do this at any level. For example, let's say that if we go into the session details page, we have a feedback widget here. Let's log in. Let's say I'm going to log in as a speaker. It's errored again. OK, I need to just remove this for now. Refresh. All right, so I go in here. We see loading session details. The entire page tries to load. Need to log in again as a speaker. The entire page starts loading. We see the fallback here. And then the entire page shows up. Now, this page has multiple requests to the server for things. It's trying to get the session details. It's trying to get the speaker details. And it's also loading the feedback widget and its data. Let's say that on this page, this feedback widget is less important. We don't want to hold the entire page before all the data is ready, because this is a less priority area. So the way we solve this is very simple. Go into session details. We have our feedback widget here, where we check if it's an attendee, show the attendee rating component. If it's a speaker, then show the speaker review component. This is actually very similar to the app that I built for Momentum. So if you get a chance to check that out, thank you. OK, so we can simply wrap these components with its own suspense. We save it. Now if we come back here, we're going to see the feedback widget has its own spinner now, or has its own loading state. So the reason this is powerful is we can decide these loading and error states based on our UI and not based on the data. And if you think about if we have done any UI designing where we're just trying to come up with prototypes or mockups of what the UI looks like, or if we have designers working for us that are giving us Figma designs, they don't think in terms of data. Designers think in terms of UI. What happens if this UI isn't ready? Or what if something here goes wrong? It's never about what if we are still fetching the speakers while the session is fetched. That's not how we design UIs. So this idea of suspense and error boundaries fits right into our UI design philosophy or UI design approach. OK, now let's see how this actually works. How are we able to represent asynchronous states as synchronous states? So let's look into this use async data hook now. Now React, since React 19, has this operator or a hook called use. They're not great at naming. Let's give them some slack for it. But what it does is it takes a promise. So you can see that we're passing a promise of t into the hook. And what we get back is just t. If use gets a promise that's unresolved, it's going to suspend rendering that component. It's going to stop and give up the thread to something else. And once that promise resolves, it's going to try to re-render that that entire page, basically, everything under the suspense boundary. Up here, we have our async function that we pass into this hook. We just pass it into a use memo, so we make sure we don't call it multiple times. And we get back our promise. Then we use to get our value, and we return it to the caller of the hook. The implementation of this is a little hacky. If you're interested in that, we can talk about that after this talk. But that's kind of how it works. The other thing we have here is kind of a global cache. It's because when React re-renders a component, it needs to make sure that it receives a resolved promise instead of an old promise. Once again, I'll get into more details about this soon. Let's see what else we can do here. What if I click on this button? I'm going to click on this, but then everything goes to fallback again, because after we are done toggling the bookmark, we refetch the bookmark. So the suspense gets notified that, hey, we are trying to refetch something. This UI isn't ready. Go to fallback. Same thing here. If I say, I loved this keynote, submit. Once again, we see the loading feedback widget, because everything goes back to fallback. We don't always want that. If there's existing data, existing content on the page, we want to continue showing that while we are doing our async work in the background. We only want to show fallback when there's nothing to show on the screen. So let's see how we can fix that. Technically, before we added any suspense boundaries, that's what it was doing automatically. It was keeping the current state of the UI and trying to render everything in the background. Suspense is kind of a way to opt out of that. Suspense is a way to tell React that I want to show this fallback here if this is not ready, instead of waiting. But we can very easily opt back in by using transitions. This is another thing that we get from React. And inside a transition, we change some piece of state. So here you can see that we are just toggling this fetching Boolean. And every time this is toggled, it's going to run our async function again, because it depends on fetching. And when the async function runs again, we get back a new promise. And when use receives a new promise, it goes to fallback again, or it suspends. Transition is a way to tell React that, hey, if this state update causes any suspense boundaries to go to fallback, let's not do that. Let's show the existing UI until everything is ready to be shown on screen. So let's save it and see what it looks like now. So now when I hit this button, it just goes on. We don't go back to fallback, because now we are refetching the bookmark inside a transition. Same thing here. Let's change this to I hated this keynote. Submit, and we don't go to fallback. We keep showing the current UI for as long as we can. So these are the two features: suspense to show fallbacks, and transitions to kind of opt out of them and keep the current UI whenever we want. These are our new controls for asynchronous UIs, instead of having to handle the states for every data operation. OK, what's next? So let's recap what this new suspense model gives us. We get to represent async states without the intermediate states, or without being forced to represent the intermediate states. We also get automatic cleanup of things that we don't need anymore. So if we switch from day 1 to day 3 in our schedule page, it can automatically discard the asynchronous results of day 1 and make sure that we don't see any intermediate state or the wrong state flicker in, or we don't get stuck there. We get inversion of control. So something higher up decides what happens if we get into an async or error states for everything below it. We get view-scoped fallbacks instead of data-scoped, which, again, is nice in terms of UI design because it's better to think about these states as part of our UI than additional data. And then we get transitions to do a bunch of things in the background, like refetch some data or post a post action or a delete action, and keep rendering our new UI in the background and only show it once it's ready. That said, this model comes with some challenges that we have to keep in mind. It's render blocking. What that means is as soon as we try to access some asynchronous state using that use hook, it's going to suspend that component. It's going to suspend rendering it, and it's only going to try to re-render it from the top once the async resolves. This means if you have another fetch right below it, it's not going to execute until the one above it is complete. So you get a lot of intentional waterfalls. This also means you need, like I mentioned, a way to cache the promises outside of React's lifecycle. I'm going to show a demo of all of this in a second. OK. Oh, yeah, the promises have to be executed eagerly. Promises in JavaScript are not lazy. They're executed immediately. This means when you try to read from a promise or inside React, it's going to stop rendering all of its that component. It's not going to render its children. And so if you need to avoid that, if for some reason you want to continue rendering that component and reach other things first, you have to pass that promise around to its children. You cannot just pass the data. You have to keep the promise inside your React component, pass it down to your children, and your children component now need to accept a promise instead of just regular JavaScript objects. And finally, like everything else in React, it's scoped to the component. So if you want a suspense fallback for some component where you're fetching some data, you have to wrap that with another component where you use the suspense boundary. You can't just do it inside that component. Yeah, so because of these reasons, it's kind of dangerous to just do data fetching directly in React without additional help. And React recognizes these problems, which is why they recommend using a framework like Next.js or Remix, because we need those additional systems to solve some of these problems for us. OK, let's see what it actually looks like. OK, so I have a new demo here. I am going to say, let's go to the counter component. OK, so this is a much simpler demo. We have a hello world here. We have a button. It's a simple counter button. If I click on this, let me make sure this also doesn't keep erroring all the time. Where is my counter? Oh, here we go. So once again, I'm randomly throwing some errors here. Let's not do that for a bit. OK, so we have a counter here. Every time I click it, it loads a new phrase for the number on the counter, like that. I can click it a few times. And we see that while this message is being loaded, we show this loading state here. It's pretty simple. How do we do that? Well, we have our counter state, our number. We have our use memo, where we call the getHello function. This is just the hello world message that we get here. We're also getting that asynchronously. And we're doing that because when we refresh, for a little bit, you see this loading phrase counter up here. It's doing that while it's trying to fetch this message from like some asynchronous stored. Yeah, so, and then we have another fetch here for our phrase based on the number. So which is a promise of string. And when we come down here, our message component needs to accept a promise of a string, and it then uses that to get a string back and show it in the UI. Now, this message component needs to be wrapped, or we wrap it with the suspense and error boundary to make sure that if something goes wrong in fetching our phrase for our number, it can be handled right here. But we can't exactly do that. There's a couple other problems here, actually. We fetch this hello, and we only start fetching this phrase once this completes, because it's on the second line. If I invert the order, it's actually going to be now fetched in parallel, because this use is the second line instead of the first one. It's going to be worse if I just add the use here, because now, sure, we can pass the string directly into our message component, but then these two won't work anymore, because we're calling use up here, which means this entire phrase counter now needs to be wrapped with its own suspense and error boundaries. I wish I had time to go into some of the more problems here, but looks like I'm running out, so I'm very quickly going to the final few slides here. Small correction. These are the problems that we run into if we use Suspense with React. Luckily, that's not the only framework these days that implements Suspense. Because SolidJS kind of has a habit of taking everything that's nice about React and supercharging them with fine-grained reactivity at the small cost of having to use signals. So you can see that all the problems with Suspense in React kind of get turned into things that are enabled. Let's see what I mean by that. This is the final demo. I'm going to mirror again. So this exact same component I have built here with SolidJS. This is an experimental build of the next version, the Solid 2.0, what we're calling it. The current version of Solid will give you most of the same benefits, but I just really wanted to show some of the cool stuff that we have been doing with the next version of Solid. So we have create signal, which is similar to use state. This is how you store any bit of state here. You can set it, and you can read it inside your components or anything that's reactive. Then we have create async, which you can think of as a combination of use and use memo in React. It's going to take the same thing, a promise of a string, or at least a function that returns a promise. And it's going to give us an accessor of a string. Again, it's not a string or undefined. It's just a string. We can also do cool stuff. You can see it here. This phrase, again, we are fetching some asynchronous data in here. But when we call the phrase, we just get back a string. We don't get back string or undefined, and we don't have to add a question mark here. The other cool thing here is we can add a suspense right inside the component. And because Solid is expression scoped, not component scoped, this is the binding. So this hello message comes from async. But this is the binding, this one line of expression. When this runs, it's going to notice that, hey, this message or this hello message isn't ready yet. We are still fetching it. And it's going to notify the suspense right above it. So it's not based on the component. It's literally based on the expressions in your templates or in your JSX. Also, we don't need to pass promises around. We can just pass the props text as string. And we can pass our, let's say, upper phrase, or this is where we turn the phrase into uppercase. We can actually just get rid of that for now. And let's say phrase, and here, phrase. So we can just call our asynchronous data or asynchronous signals right here, put it inside the message, and we are going to try to read that right here in our, inside our inner component. And if this is still loading, or if it errored out, this is the binding that is going to notify any suspense above it. So again, you don't need to keep passing promises around if you need to handle some loading state downstream. And obviously, the other big benefit here is that the order here doesn't matter. They're always going to be fetched in parallel. In fact, even if we move this create async in our inner component, so which is rendered inside our counter, it's still going to be fetched in parallel, because that's just how signals work. And obviously, you get error and suspense. And the final thing that is a very recent addition are error fallbacks get this handy retry method. So you can just use this for add a button in your error UI that says that here's how the user can retry. Now, the retry doesn't just try rendering inside the error boundary again. It can literally refetch the data up here. The error boundary is nested inside the component. The create async is up here. But if this create async fails, because signals are a data dependency graph, we know that this data failed or this fetch failed. And that's what caused this binding to fail, which triggered our error boundary. So if you retry the error boundary, it's going to say that, OK, I want to try to render this again, which is going to walk up all the way to here, because it's a graph, and it's going to ask it to retry. So it doesn't really matter what async went wrong. There's always there's a very simple way to just retry whatever went wrong inside your system. And obviously, you don't need a global caching solution, because a reactive system automatically is a cache. I really wish I had more time to go into everything here. But I thank you all very much for coming to my talk. This is, again, the TLDR. Synchronous state is simple. Asynchronous state tends to be complicated. And we have finally tried to find a way to make it relatively simple. So if you're building anything asynchronous, feel free, please try to use these new primitives in React, in Solid. Vue and Svelte are coming up with their own versions of this as well. So this is something that you'll find in the JavaScript framework near to you. Thank you very much.